Okay, so we'll see an introductory tutorial to VLAN or virtual LANs. Let me start with an example that I can use to motivate the need for setting up a VLAN. Okay, so let me start with a switch. We'll use a switch. Let me use computer generic PC. I'll use 4 PCs. Okay, and let me connect them. So we're connecting a PC to a switch, so I'll need to use a straight through cable. So click on fast Ethernet. I reserve the first two interfaces for something else. You could use any of these interfaces. So each is a port. Okay, so this is one port to the switch, second port, third port, and so on. So we'll use the third port. So now the switch and the PC will communicate to know each other basically, so that the switch will learn about the PC's MAC address. Now let me connect the PC to this interface 4, then this one to this. Okay, select fast Ethernet, connect to this. So now you see one of them turned green. So basically after the switch learned the MAC address of this switch of the PC, it will enable that interface. Okay, so let me just label them. We are not configuring any IP address yet. Let me just label. So let me say I will give this PC MAC IP address of say 10.10. Let me give this PC 10.11. Let me give this 10.12, and let me give this 10.13. I'm just labeling them. Okay, alright, so now everything turned green. Alright, so let me go to each of them. So I'm going to configure their IP address now. So I'm going to enter the same thing. This is its IP address, and when you press the tab key, the subnet mask comes automatically. Okay, so let me close this. Let me set up the IP address for this. So this is a static IP address, so you are manually configuring them. Alright. Okay. Alright. So this is a 10.0 prefix. Okay, so that's why we gave 24-bit subnet mask. Alright. So if 10.10, this machine wants to send something, say, to 10.12, then it has to know whether that machine is in the same broadcast domain, same network, basically. So for that, it will try to do a bitwise subnet mask with bitwise AND with its own subnet mask, right? So this is a destination machine, so you're doing this at 10.10, right? So we'll do a bitwise AND with this. We'll get what? 192.168.10.0. So it matches with the subnet network prefix for this 10.10 machine too, because that's also on this 10.0 network, right? So once it determines that the destination to which it wants to communicate is in the same network, it tries to find its MAC address. Now it doesn't know its MAC address, so it will do an ARP broadcast to find the MAC address of that machine, 10.12 machine. So once the 10.12 machine sends an ARP response, ARP broadcast is for asking about the MAC address of a machine, a particular IP address. Then that machine with that particular IP address responds back with its MAC address. Then 10.10 can directly communicate with 10.12, so it sends whatever the packet it wants to send. Right, so each of these machines will be connected to the switch. So the switch knows the MAC address of each of these machines. So when 10.10 wants to send to 10.12 using its MAC address, it will send the packet, because everything that is coming out of this PC has to go to the switch, right? So when the switch gets it, it looks at the MAC address which corresponds to 10.12, so it sends the message out on that interface. So we can really simulate this using the ping command. And let's say 10.10 wants to ping to 10.12. Okay, so let me turn on the simulation mode, and so by clicking on this icon, so when I say show all, edit filters, all the different protocols that can be run show up. So I click on the show all to turn off everything. We want to see the running of only ARP and ICMP. So click somewhere outside. So now we will let's click on auto capture play. So you will turn on a packet, click on this packet. We want to ping from here to here. So let's see what happens. You see, this is an ARP request going from 10.10 to the switch. The switch sends the broadcast of the ARP request, and only this machine responds back with the reply. Right? So now this sends the ping message, echo request message, and it goes to this. This sends back the reply, and the reply comes back to the sending host. Right? So that's what happens. Let me try for another thing. Let's say 10.11 wants to ping 10.13. So 10.11 doesn't know the MAC address, right? So let me slow down this little bit. So you can see. So I click on the packet icon, put one here, put one here. So that's the source and this is the destination. You see, this is the echo request. For that, first the ARP has to go out, so the ARP request goes to switch. So the switch now will broadcast to all the machines connected to its LAN. Okay, so all the machines are in this LAN, and that guy sends back the ARP response with its MAC address, and the switch now forwards the MAC address to the response to 10.11. So now this guy can send the echo request message. It will go only to this machine, and this machine can then send back the echo reply, which will go back to 10.11. Alright, because from the request message 10.13 can also learn the MAC address of 10.11. Okay, so let me click on auto capture. That can stop this. Okay, alright, so you can delete this thing. Alright, so the motivation is all the machines appear to be on a single LAN, so that a broadcast sent from one machine really goes to all the machines, right? And the reason for that is they are all in the same 10.0 prefix, but another thing that also makes them to be felt on the same LAN is when you connect all of them to the switch, right? So I double click on the switch now to get this. When you go to the config screen, and we saw this is 0/3 interface, right? And if you just place your cursor on this, since it is like, okay, let me place it. This is 0/3, 4, 5, 6. These are the different interfaces. Alright, so let's go, just click on the switch. So if you click on the 0/3 interface, you can see it is in VLAN 1. Before that, let me go to the VLAN database. If you click on the VLAN database, you can see the different VLANs that are available over there. By default, everything that you use to all the ports for the Ethernet, all the fast Ethernet ports that you have, or the interfaces that you have for Ethernet, are all put on VLAN 1. How do you know that? Just click on each of this. You see here they're all on VLAN 1. Okay, all these Ethernet interfaces are on VLAN 1. Okay, so that's the default VLAN. So that's the reason when you send a message to this switch, of course they have to be on the same network prefix. If you put them on some 20.12 and 20.13 with the 24-bit subnet mask, then of course they are in different networks, so the message won't be broadcast. But if they are all on the same network prefix, alright, if they are all connected to the same switch to fast Ethernet, then they are on the same VLAN. Okay, so what we want to do now is we want to put all of them in the 10.0 prefix with the 24-bit subnet mask. We don't want to choose a different network prefix, but we want to put them in separate LANs. So we want 10.10 and 10.11 in one LAN, and 10.12 and 10.13 in another LAN, basically. Okay, so with the same 10.0 network, 24-bit network prefix. So what we could do is we could create a second VLAN. So let me click on the VLAN database, add VLAN number 2, and put it as VLAN 2 or anything you want. So if these are, say, department names, you can say name this as department A, department B, and so on, and click on add. So now you're adding the second VLAN. Now we need to add which interfaces you want to put on VLAN, the default VLAN, and which one on the second VLAN. So let's put these two on the first VLAN. By default they are there already, so we will now put 10.12 and 10.13 on the second VLAN. So 3 interface 0/3 is the first PC, 10.10. This is the second PC connected to this, so 0/5 is the third, 10.12. so click on this, select this, right, VLAN 2, then 0/6, click on this, click on this, this is VLAN 2. Alright, so now they are in different VLANs. So these two are in one VLAN, these two are in another VLAN, right? So it will take a while for them to get it configured. So then they'll turn green. So already one has turned green. Alright, so let me wait for this to turn green so that we can simulate it. So let's say now 10.12 has not sent any ping to 10.13, right? So 10.12 doesn't know the MAC address of 10.13. So if you want to simulate this ping command now, with ARP and ICMP turned on, let's start auto capture. And let's say I want to send to this. Now we'll see the ARP request message will go to only 10.13. It won't go to these two machines because they are in a different broadcast domain, right? So that's ARP request going to 10.13, so that will respond back with a reply, and the reply will be forwarded back to this guy. So this has now learned the MAC address of 10.13, so now it can send the echo request, and this switch will forward the echo request to that computer, okay, and it will send back the reply, and the reply will go to this computer. Alright, so I can stop this. Okay, so this is the purpose of VLAN. You can actually, one of the main purposes. Later in another tutorial we'll see another reason why we need a VLAN. But within the switch, if you have multiple machines connected and you want to segregate them into multiple broadcast domains, then we can put them in different VLANs like this. Okay, so otherwise, if you put all of them in one broadcast domain, any broadcast kind message like an ARP request message sent from one machine will be broadcast to all the machines. Of course, unicast messages will be unicast only to the respective machine. Once, like the ping message is not broadcast even if when all of them are in the same domain. It was sent only from this PC to this PC, but this PC had to learn the MAC address. So for that, it has to do an ARP broadcast, and that broadcast will be sent to all the machines if they are in the same broadcast domain. So that's why we segregate them if you want to. So also, like if you have multiple departments in an organization, you could connect all the computers to a switch, but if you want to control the communication, you need to segregate them into multiple domains. So now you can also test the ping command. Sorry. Okay, so you can ping from 10.10 to 10.11 because they are the same network prefix 10.0 prefix, as well as they are in the same VLAN, right? But when you try to ping to this 10.13, let's see what happens. Previously, we saw 10.10 was able to ping to 10.13, right? Because they were the same broadcast domain, same VLAN, and they had a 10.0 prefix. But now, even though they have the same 10.0 prefix, since they are in different VLANs, we cannot reach from this computer in one VLAN to this computer in the other VLAN, right? So if you want to communicate between machines in different VLANs, we have to go through a router. Okay, so which we'll see in the next tutorial, right? So let me stop with this.